we need to evaluate this integral from 0 to 5 absolute values of 3x minus 1 dx. So I recall the definition of absolute value. Say absolute value of a equal to a if a is greater than or equal to 0, equal to minus a if a is negative. So with that, you have absolute values of 3x minus 1 equal to itself 3x minus 1 if it is non-negative, 3x minus 1 greater than or equal to 0, and equal to minus 3x minus 1 if 3x minus 1 is negative. So a, you think of that here as 3x minus 1. So this one is written as 3x minus 1 if 3x minus 1 bigger than or equal to 1, 3x bigger than or equal to 1, x bigger than or equal to 1/3, x bigger than or equal to 1 over 3, and 1 minus 3x if x less than 1/3. Now we can write down this integral. We look at 0 to 5. So 0 to 1 over 3, 1 over 3 to 5. Break it into two parts. 0 to 1 over 3. Absolute value 3x minus 1. I just let it be for now. 1 over 3 to 5. Absolute value of 3x minus 1 dx. And we know that when x less than 1 over 3, this absolute value is 1 minus 3x. 0, 1/3, 1 minus 3x dx. And the second one, 1/3 to 5, 3x minus 1 dx. Now we compute that separately. So if you are comfortable with computing integral, we use the fundamental theorem of calculus, right? Compute the antiderivative of this, and then plug that in. Another method is to just draw the figure. So for example, method 1, if I want to draw the picture and compute the area under the curve, so what we have is, we know that either way is the absolute value, right? It's all way above the x-axis. So this is the area under this curve. So if we sketch the graph, x from 0 to 1/3 and 1/3 to 5, 1 over 3, and let's say 5 is here, x and y. The first one, 1 minus 3x, is going down like this. It's passing through this point, and when x is 0, it is 1 minus 0 equal to 1. So let's say 1 is here. Let's say 1 is here. So the line must be this one, passing through this point and this point. So you scale it a bit, 1 should be like over there. I just sketch the graph. That is the first one. For the second one, 3x minus 1. So first of all, it's passing through this point. X equal to 1/3. 3 times 1/3 minus 1, 1 minus 1, 0. Second point, I could just let x equal to 5. X equal to 5. 3 times x minus 1, 3 times 5 minus 1 is 14. So it is passing through 5, 14. So I can draw the lines passing through this point and 5, 14. Let's pretend that 14 is here. So 5, 14 is this point. So here's a graph of absolute values of 3x minus 1 when x between 0 and 5. Integral here is area under this curve plus area under this curve. So area under the yellow one, so this yellow region, and say green region, this one. You can compute the area of two right triangles, and you take a sum. This length is 1/3. This length is 1. Area of the region 1 is this integral. Is the area of region 1. 1/2 times 1 times 1/3, so 1/6. The area of region 2 is this integral. Area of 2. So this length 5 minus 1/3. 3, 15 minus 1, 14 minus 3, and the other side, this length equal to 14. So 1/2 times 14 times 14/3. So 14 times 14, 196 divided by 6. And therefore the total area, which is this integral, equal to area of region 1, 1/6, area of region 2, 196/6, which is 197 divided by 6. So that is answers. And here's how we did it with method 1, compute the area. Let's do method 2 then. Compute this integral using the theorem. Method 2. So we have antiderivative of this one, x minus 3 times x squared over 2, x from 0 to 1/3, 3 times x squared over 2 minus x for x from 1/3 to 5. Now we compute each one of these. For the first one, 1/3 minus 3/2, 1/9 minus 0. For the second one, 3/2 times 25 minus 5, and then minus 3/2, 1/9, minus minus, so plus 1/3. What I did was I just plug in x equal to 5 and 1/3 here. So we compute that. 1/3 minus 1/6, because 3 and 9 here cancel out to 3. 3/2 times 25, we cannot do anything with that. So 75/2 minus 5 minus 1/6, 1/3. Compute this one, we have 1/3 plus 1/3, 2/3, minus 2/6, 1/3. 75 divided by 2, 10 divided by 2, 1/3, 65/2. Common denominator 6, 2, 65 times 3, so 5, 18, 19, 197/6, So it is the same as the first method. You do either way. You should expect to have the answers 197/6, which is an integral. This one.